In this video, we will learn how to solve problems when we don't know the mean or standard deviation. Suppose that the lifetimes of a certain kind of light bulb are normally distributed with a standard deviation of 110 hours. If exactly 99% of the bulbs die before 900 hours, find the mean lifetime of the bulbs. Carry your intermediate computations to at least 4 decimal places. Round your answer to at least 1 decimal place. So let's take a look at what we know. We know that the lifetimes of this kind of light bulb are normally distributed, therefore I can use the normal curve to base my solution upon. I am also given the standard deviation of 110 hours, so I record that. I don't know the mean. It says to find the mean if exactly 99% of bulbs die before 900 hours. So I need to find where approximately 900 hours is, and it must be in the far right side. Why? Because there must be 99% of data to the left of that quantity and only 1% on the right side, in the right tail. What do I do now? I don't know the mean. And the only way for me to connect what I know to what I don't know is to introduce z-scores. Why? Because there is a formula, z equals x minus mu over sigma, and I know the x value of 900, I know the sigma of 110, I want to know what mu is, that's my unknown, and if I can only find the corresponding z-score to this x, that would give me an equation with only one unknown, mu, and I can solve an equation with one unknown. How do I achieve my goal of computing a z-score corresponding to this given x of 900? Well, I can use the inverse norm because I know that whatever this z-score is that corresponds to 900 hours, it must have 99% of data to the left of it. So z sub 0.01, which is this location, because it has 1% of data to the right, will be equal to inverse norm when 99% of data is to the left side, and of course on a standard normal curve, mean is 0 and standard deviation is 1. This results in 2.3263 as the z-score that separates 99% of data on the left from 1% of data on the right side. Now that I know the z-score, I will input it into this equation as well as x of 900 hours and sigma of 110 hours. This yields the following equation. I think it may be useful if I clarify what happens next. I have an equation that has fractions, and I would prefer to clear fractions, so I'm going to multiply both sides of this equation by the denominator of 110. This will make it possible for me to reduce 110 with itself on the right hand side, and 110 multiplied into 2.3263 results in 255.893. The rest of it is just trying to get mu by itself, and when I'm done with this process I get mu approximately equal to 644.1 when rounded to 1 decimal place as we are directed in the assignment. Let's try one more problem of this type. Suppose that the TSH, thyroid stimulating hormone, levels among healthy individuals are normally distributed with a mean of 3.3 units per milliliter. Suppose also that exactly 95% of healthy individuals have TSH level below 6.2 units per milliliter. Find the standard deviation of the distribution of TSH levels of healthy individuals. Carry your intermediate computations to at least 4 decimal places. Round your answer to at least 2 decimal places. Let's find out what we know. We know that the distribution is normal. Therefore, I am allowed to use the normal curve as basis for this solution. I am given the mean of 3.3 units per milliliter, and I know that exactly 95% of individuals, this group, has levels below, which means less than or to the left of 6.2 units per milliliter. So 6.2 is right here, and it separates 95% of data from the top 5% of data. Just like in the previous example, I'm going to tie this to a z-score corresponding to this x value. So z-score will be z sub 0.05, because there's 5% of data to the right of this x value, which is equal to inverse norm of 95% of data on the left side. 0 is my mean, and 1 is my standard deviation. And of course, please remember that we always think of this area to the left, just to clarify. And it happens to be that the z-score corresponding to the 6.2 is 1.6449. Now I go back to the equation that connects z and x values. Z is equal to x minus mu over sigma. I know z, I found it to be 1.6449. I know x is 6.2. Subtract that with mu of 3.3 and divide by sigma, which we don't know yet, but that is what we want to solve for. So first of all, I subtract 6.2 and 3.3 and I get 2.9. Now I can do the cross multiplication because I have two ratios comparing to each other. Cross multiplication gives me the next line here. 1.6449 sigma is equal to 2.9. Division on both sides by the coefficient of sigma yields sigma to be 1.76 when rounded to 2 decimal places as requested.